Today's video aims to be a Meteora 101 for folks that are looking to try it out, but have yet to understand the mechanics behind this novel product, the dynamic liquidity market maker. An important disclaimer is that in this video we won't get into the more technical aspect of things, but rather aim to give a comprehensive view of what Meteora is and why you should give it a try. So, today we'll be talking about four main aspects. First off, why should you prefer Meteora over the alternatives? To prove this point, we are going to explain the evolution of liquidity providing, starting from Uniswap V2 pools, the V3 pools, and finally Meteora's DLMM. We will then focus on the main features of Meteora's product, and understand what are the parameters governing each LP so that you can make informed decisions. Furthermore, we will delve in particular into perhaps one of the most interesting features of Meteora, distributing liquidity over a set price range. Finally, I will give you a couple tips on how to choose your liquidity pool and which is the most suited for your needs and goals. So, why Meteora? Why should you use it and try it out? There you can see the three main evolutions of liquidity pools. The first one represents the Uniswap V2 model. There you can only provide liquidity in an infinite price range, meaning that for each pair of tokens, there will be liquidity from 0 to infinite. The pros of this model are its simplicity and low maintenance, allowing for a set and forget mindset. However, oftentimes it was clear that this was inefficient, and the only way liquidity providers kept using it was for liquidity incentives, using the project's token. This model was not sustainable in the long term, and the model was inefficient because trading is often concentrated within a set price range, whilst liquidity is not. Hence, traders were getting higher price impact on their swaps, because they couldn't tap the unused liquidity sitting idle in the rest of the price range. So here comes the Uniswap V3 model, with the concentrated liquidity pools. The main update here is that you could choose a set price range in which to provide liquidity. The narrower and the more concentrated your LP was, and the higher the fees you could earn. This innovation made it possible to require lower liquidity, but set on the right price range to achieve the same price impact you will get using Uniswap's V2 model, hence partially solving the inefficiency issue and the need for massive inflationary liquidity incentives programs. Some issues have arisen with it. Narrow ranges often had to be repositioned because falling out of range, meaning they stop earning fees. Plus, the distribution of fees still has to be uniform along the price range, not allowing for personalized distributions based on each pair's market volatility. So here comes Meteora and its DLMM. With it, you not only can customize the distribution of liquidity on a set price range, but you can also decide to provide single-sided liquidity, which is in particular useful in token launches or in general in DCA strategies, dollar cost averaging. But most importantly, Meteora's DLMM pools slice liquidity into a certain number of bins along the price range, which is inherently different from what Uniswap V3 pools do. Each bin contains a certain amount of X tokens and the amount of Y tokens you need to get those X tokens. So the price in each bin is predetermined, allowing for zero slippage trades within each one. Say a bin in the Sol USDC pool contains 1000 USDC and it has a price of 100 USDC per Sol. In this case, a user will be able to deposit 10 Sol inside that bin and get exactly 1000 USDC out of it, minus of course the pool fees, which we will see later. However, you could still suffer from price impact on your trades. In fact, as a bin is emptied, you have to move to the next one, and the more volatile and illiquid the pair, the more the bins are distant from one another. Their distance is, in fact, a price impact you will have to stomach. Awesome! Now that we have gone through the liquidity pool's evolutions, let's summarize why the DLMM could fit your needs better than the concentrated liquidity model. So, why the dynamic liquidity market maker is superior to the concentrated liquidity model. While the CLMM reduces price impact on a set range because of higher concentration, as we saw before, it still has an impact. Meteora instead offers a zero slippage inside each bin, as the price for each bin is predetermined already. This unlocks higher capital efficiency, potentially higher volume, and as a result, more fees for liquidity providers. But there's much more to it. With DLMM, you are not required to provide liquidity in a 50-50 ratio. You can decide to provide a non-balanced liquidity, for example in a 70-30 ratio, or even provide single-sided liquidity, meaning you are only providing one token. This comes handy for dollar cost averaging strategies and token launches especially. Also, this suits everyone. Liquidity doesn't have to be provided uniformly over the price range, but can be distributed using different curves that suit different strategies and risk aversion profiles. Finally, you will find that for the most traded pairs, Meteora offers different pools, each with a base fee and a max fee. Within this range, you will find a dynamic fee that moves along the fee range based on the market's volatility. This in particular helps to offset liquidity providers' losses when the market moves too fast. With that being said, we can take it to the next step and open a random Meteora DLMM pool to analyze its key parameters. So, this in particular is the Jupe USDC pool. On the left you can see the total value locked in dollars, and this is the total amount of assets deposited in this pool. While on the top right corner you will find the fees earned on average by liquidity providers in the last 24 hours. That is, in 24 hours the pool generated 0.51% of the TVL in fees. This is then distributed to liquidity providers based on their strategy, meaning that some are earning more and some less than this average value. This value is often misread, as people mistake it for the APR of the pool. Instead, this represents the daily amount of fees generated. To get the APR, you should multiply that by 365. Let's now switch to the pool's parameters on the left. As you can see, the first value is the bin step. This represents the distance between each bin in basis points, where 1 basis point equals to 0.01%. The more volatile the pair is, the higher the steps you will find. We then have the base fee, which is the minimum fee you will pay as a trader to use this pool, and will of course earn as a liquidity provider. There is also a maximum fee that can be reached thanks to the dynamic fee mechanism. This mechanism increases the fees as volatility picks up, as a way to offset potential liquidity providers' losses in a high volatility environment. This is particularly useful, as it reduces the maintenance on one's position, so that instead of having to constantly switch pools as volatility picks up, Meteora helps by adjusting the fees itself within the pool. However, this may not be enough sometimes, and you may still be required to switch pools, but we will see that more in depth later. Then we have the protocol fee, which in that case is 0%, but might be turned on by Meteora to generate revenue sometimes in the future. Finally, we have the fees accrued in 24 hours. If you multiply the percentage figure in the top right corner for the TVL, you will get the same number. But let's move on, as it's in the middle of the page that the real fun begins. At the top you will find useful indicators of the liquidity you provided, the fees you generated, and the amount of tokens in your LPs. You then have 3 tabs: your positions, add position, and an in-app swap tool. On the right, there's also a button to refresh the rates and another one to set the priority of your transactions, which is handy when the chain is congested, for example during token launches, and the slippage you are willing to accept when creating the position. Down below, there's a model allowing you to input the desired amount of tokens you wanna provide as liquidity. If you leave the autofill enabled, the system assumes you will provide liquidity in a 50-50 ratio, and will thus complete the order token amount as you input the first one. However, to provide non-balanced or single-sided liquidity, you should disable this autofill feature. Finally, we've gotten where the magic happens: the distribution curves and the price range. We will see in the next few slides the 3 curves you can choose from: spot, curve, and bid-ask. Not least important is the price range. Down there you can set the minimum price and maximum price within you will be providing liquidity. You cannot widen it more than what is specified there, as you will need to find a pool with a higher bin step, but you can narrow it down to achieve greater concentration. What this means is that if you nail it, and the pair does in fact trade only inside the narrow range you selected, you will be earning more fees than those who use the wider range, which explains why the fees accrued represent the average, as some are earning more and some less than that. Having understood what the key parameters in a pool page are, we can move on to analyze the three different types of distributions to choose from. So there we have the spot distribution, possibly the easiest to understand and implement. It mimics the concentrated liquidity model, but still it uses zero slippage bins, and is considered to be highly versatile. As a pro, it is the best suited for set and forget strategies, and used on a wide range, that you may not have to rebalance often. On the other hand, this distribution is not the most efficient in any given situation, but overall yields discrete results. If most trading happens at the middle of your distribution, you would be better off by using a curve distribution, while if most trading happens on the tails, you would be better off using a bid-ask distribution. With that being said, always chasing max yield and thus efficiency requires to put in the work and rebalance often. A spot distribution is the best choice for individuals that are looking for an easy to deploy and low maintenance solution, where the trade-off, of course, is earning less fees than the more active operators in the market. Let's now move on to the curve distribution. This distribution concentrates liquidity in the middle and is best suited for pairs that tend to have low volatility and trade in the middle of our price range. The prime example for this are stablecoins. This way, you are maximizing the fees you will earn in the middle of your price range, but the trade-off is that you will earn less fees on the tails. Compared to the spot distribution, the curve one requires more maintenance, often requiring you to rebalance your position, unless in the specific case of a stablecoin, where unless a depeg happens, it could likewise be a set and forget solution. Finally, we will go over the last and perhaps more complex type of distribution available, the bid and ask. This might remember you the order books of an exchange, and you wouldn't be mistaken, as it follows nearly the same pattern. It's actually the inverse of the curve distribution, with the liquidity concentrated at the edges. This means you will earn more fees than average when the pair trades on the tail of your price range, and less fees when it trades in the middle of it. This makes it ideal for highly volatile pairs that tend to swing from one end of the range to the other. As the curve distribution, the bid and ask model requires more maintenance than the spot one. An interesting application for it is dollar cost averaging, when providing single-sided liquidity. Using the pair in the example, you could provide PIT single-sided, starting your range from the actual price to an higher one you deem appropriate. Given this distribution, as price rises, you will be selling an incremental amount of PIT in exchange for USDC, earning more than you will do by doing the same using a spot distribution. So, the last point we will be discussing today is how to choose pools. As we mentioned before, pairs with great volume will have different pools for each pair. This means that aggregators like Jupiter will route swaps choosing the most convenient one. As a rule of thumb, in highly volatile periods, orders will be routed to higher fee pools, while in lower volatility periods, orders will be routed to lower fee pools. While the dynamic fee lends you a hand with that, you should consider this rule of thumb when choosing in which pool to provide liquidity. Another thing to consider is that by skimming through pools, you will also notice a pattern, where pools with a higher base fee also have wider bins, hence a wider price range, and pools with a lower base fee also have narrower bins, hence a narrower price range. This is important, as with narrower price ranges, it's easier to fall out of range as price moves and stop earning fees. Lastly, when you are trying to choose between the different pools for a certain pair, and you have already done your considerations in regards to the width of the price range and the fee, a crucial piece of information is how much volume is routing through each of these pools. In fact, you shouldn't be fooled with a mere volume figure, as a pair that's only doing $10 in volume on a 1% fee is earning more fees than a pool doing $100 in volume but on a 0.05% fee. While this can be checked on Meteora's DLMM page by searching for a pair and sorting by accurate fees as a percentage of TVL, you can analyze the data by also going on DEX Screener and sorting all the pools for the volume they are generating over a certain time frame. This is especially useful in a shorter time frame. So that was everything. We hope you liked this video, and should you have any questions, feel free to ask them below and I will do my best to answer. You will also find some resources in the description to further consolidate your knowledge on Meteora DLMM pools. Happy farming!